Hey you guys, I just want to real quickly go over the test review, the second half. We left off on number 12, so this would be number 12. Alright, so they give us this image right here. It says, following the route shown, what is the total distance traveled around? If it ends where it started, what properties and theorems would you use to find that? So look, 350, 350, so these are congruent. 300, 300, these are congruent. They've already got these angles right here marked as congruent. So the two triangles are congruent by side angle side. So the triangles are congruent by side angle side. Well, since these triangles are congruent, then if this is 200, this is 200. So I'm just going to write the third side equals 200 feet. And that's because corresponding parts of congruent triangles are congruent. So I'm going to put CPCTC. All right, and then they want to know how far would it be all the way around both of these triangles. So you have two sides that are 200, here and here, plus two sides that are 300, here and here, plus two sides that are 350. And then with a calculator or your noggin, that's 400 plus 600 plus 700, which would be 1,700 feet. All right, let's look at the next one. They give us this picture. There's a couple given statements. They want me to finish this proof. So it starts out with AB is parallel to DC. That's given. And they've got AB and DC marked as parallel right here. And then they say angle BAC is congruent to angle DCA. Well, how do I know that those two angles are congruent? That is because they are alternate interior angles. So alternate interior angles. All right, and then I want to go ahead and use my next given. So I'm going to say that I know that AD is parallel to BC. How do I know that? It was given. Giving myself a little more room here. All right, well, if these two are parallel to each other, then what else can I say? Well, I can say that angle ACB, good job, is congruent to angle CAD, good job. And again, that would be because they are alternate interior angles. All right, and then we have them sharing this side, so I could say that AC is congruent to AC, and that is the reflexive property. So let's mark that. So now I have that these two triangles are congruent, right? So I can say that triangle ABC is congruent to triangle CDA, and I know that because of angle, side, angle. Okay, let's look at the next one. All right, so they give us this picture right here that says, what else do we need to know to be able to say that those triangles are congruent? Well, there's a few things. We could say if KL was congruent to, here's KL, that would be OM or MO. And if we had these two were congruent, then we would have angle, angle, side. See, angle, angle, side, angle, angle, side. That would give us angle, angle, side. All right, we could have this little piece, JK, being congruent to this little piece, NO. And if these were congruent, I'm going to draw a little imaginary line here, we would have angle, side, angle. All right, we already looked at this one and this one. So now the only thing left would be if these two were congruent, this one and this one, and if we had JL congruent to NM, then again we would have angle, angle, side. Angle, angle, side. So there's a lot of ways we could get to where we wanted to go. All right, for the next one, it gives us this picture. It says you've got some carpenters building a roof. And they have these measures, and we've already got this 40 degrees, and this is 40 degrees. So these two angles are congruent, right? And if this is a right angle, then this is perpendicular to this. So I know that this side also has a right angle. And they share this beam or sides, and I know that it's congruent to itself. So I know that these triangles are congruent by angle, side, angle. See? Angle, side, angle. And I could say that the slanted beams are congruent. So I could say that, okay, well, this has to be congruent to this because these triangles are congruent. And that's your CPCTC. Once you've proven the triangles are congruent, the corresponding parts are also congruent. All right, for the next one, I quit numbering them. All right, so this was 13. So that one was 14. The carpenter was 15. So this would be number 16. Now, it wants to know if this whole hunk of goodness is congruent to this whole hunk of goodness. So let's see what we have here. All right, right off the bat, I can say that these two triangles are congruent. So I can say that triangle ADC is congruent to triangle where are we at here? GJK. And that would be angle, angle, side. See? Angle, angle, side. All right, well, if those triangles are congruent, then this has to be congruent to this. Oh, I already see 2 slashes, so I'm going to change that to 3. So now I know that CA is going to be congruent to JG, and that's with your CPCTC. So let's look at these two triangles. They have to also be congruent now. So I can say that triangle ABC is congruent. So ABC is congruent to triangle GHJ. And I know that because of side, angle, side. So that would be side, angle, side. So here's the thing. If this triangle is congruent to this triangle, then this side is also the same as this side because all the parts have to be the same. And now we've proven that this triangle is congruent to this triangle. So that means that these sides, let's see, I'm at 5, 1, 2, 3, 4, 5, have to also be the same. And it's for the same reason that, so I could say, if I just felt froggy, AB has to be congruent to GH, and that's by CPCTC. So most definitely, these two things are congruent. So I'm going to say that ABCD is for sure congruent to GHJK. Right? And you could get from here to here with just a rigid motion, right? You remember rigid motions from the last lesson? All right, and rigid motions produce congruent figures. All right, let's look down here. All right, so for number 17, you had this lovely picture of a bridge. I know it's hard to see and I apologize, but you can pull it up and look at it on your screen. All right, so I know that this little piece right here is congruent to this little piece right here. So I know that AB is congruent to BD, and they gave us that, right? It says 30 and 30, and those are the same. All right, I can also say that angle ABC, this angle right here, is the same as this angle right here. So I don't have room here. I'm going to drop that down here. So I can say angle ABC is congruent to angle DBE. So why are these two angles congruent? Well, they're vertical angles. All right, there's a bunch I can say. You know, once you read this, they tell you about stuff being parallel lines. So if these two lines are parallel, I can say that angle A is congruent to angle D. I could also say that angle C is congruent to angle E, and that's because they're alternate interior angles. All right, so therefore these two triangles have got to be congruent, and you could do angle, angle, side. So I'm just going to put triangles are congruent. You could use angle, angle, side, and you could even use angle, side, angle. And that's it. So these distances are the same. All the corresponding parts are the same. Boom. All right, number 18. We have this lovely picture, and thank heavens it's not nearly as complicated to look at. And they want to know, are these two triangles congruent? Well, the right triangles. And 3 and 3, so these legs are congruent. And then 5 and 5 are congruent, and that's the hypotenuse, right? So you have hypotenuse leg. So I could say that, yes, so triangle JKL is congruent to triangle MNP, P by hypotenuse leg, because they have the same, they're both 5 for the hypotenuse and the legs are both 3. Easy breezy lemon squeezy. All right, let's look at the next one. All right, so they say that this is an equilateral triangle, so I'm going to go ahead and mark that those two sides are congruent. They would also be congruent to this side, but it's cut up, so I'm not going to mark it. All right, this is perpendicular, so I know that there's a right angle here also. They share this. What else does it tell us here? It says use hypotenuse leg to determine y. Well, we got it already, right? Just with what we just did. So, you know, BD is congruent to BD because of the reflexive property. And AB is congruent to CB, and that's because it's an equilateral triangle. So the sides are the same. So I could say that those two triangles are congruent, these two right triangles. So I could say that triangle ABD is congruent to triangle CBD, and that would be by hypotenuse leg. So I'm good with that part. And then it has a part 2. It says, well, what if it was an isosceles triangle? Would they still be congruent? And not necessarily. So if it was isosceles, only, you know, we wouldn't know for sure if, you know, is this the leg or is that the leg? So not if isosceles, not necessarily producing congruent right triangles. Because like I said, 2 of the sides would be the same, but all 3 sides aren't the same, so all those parts wouldn't necessarily be congruent. All right. I keep forgetting the number. So that would be 18, and then that one would have been 19. I'm sorry. All right, for number 20. All right, so they want us to do a proof. They say a flow proof, so super great. All right, so BM is perpendicular to TJ, and ZJ is perpendicular to TJ. Hey, TJ. And we know that because it is given. Well, if those are perpendicular, then I can say that angle BMT, that angle right here, and I can say angle ZJM are right angles. And that's because of the definition of perpendicular lines. I'm just going to put by definition of perpendicular lines. Well, if those are right angles, then that makes those right triangles. So I can say that triangle BMT and triangle ZJM are right triangles. And that's the definition of a right triangle, having a right angle. All right, they also give us that M is the midpoint of TJ. So that's given. Well, if this is the midpoint, then I can say that TM has got to be congruent to MJ, and that's the definition of a midpoint. All right, and we have another given. I'm going to use a different color and just kind of write that in the middle here so we can flow with it. We have BT is congruent to ZM, and that was given to me. So look at what we got here. We have that these are congruent, and because of the midpoint, these are congruent. We have that they're right triangles, and all that together will allow us to use, I'm just gonna kind of bring it all together here. Because of all that, I can say that triangle BTM is congruent to triangle ZMJ, and that is by hypotenuse leg. All right, for number 21, it wants to know if these heights are the same. And I mean, you guys, they got this part marked to congruent, so that's super. We have this part marked congruent, also super. It's a right triangle, so guess what? They are congruent. So I know that the triangles are congruent, so the triangles are congruent by hypotenuse leg. And since that is so, I know that BC has got to be congruent to QR because of CPCTC. The corresponding parts of congruent triangles are congruent. So are the stories the same? Yes, they're the same. Yes. Woohoo. And there's the explanation. One more. For number 22, and this one's easy, do not overthink it. Look at what she's got over here. All right, she's wanting to show that this angle is congruent to this angle. And she goes through this whole little spiel here, and she proves that this triangle is congruent to this triangle. Well, hello, this angle isn't an angle of either one of those triangles. This doesn't make up this whole angle. So it's not even a part of those triangles, so done. So all you have to say is angle XWY, whoop, 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 and angle YZX are not in those triangles, are not in triangle XWZ and triangle, what'd I do? I did XWZ and then triangle YZW. So you can't use CPCTC. Not in there. It looks like one word, but you know what I'm saying. All right, so done. That's it. The test is tomorrow. Good luck. I hope you have a wonderful night, and I will talk to you later.